Right, do all of you know your 3 times tables?
Yeah.
Are you sure?
Yeah.
Right, can we quickly go through it, please? 3, 6.
Isaac Anoom, Mr Numbervator, was invited into Mount Pleasant Lane School to take a Year 4 class in problem solving.
OK, but I've got a problem here. I want to know, is 123 in the 3 times tables?
Isaac, you chose to do a pattern spotting activity for the problem solving with Year 4. Do you feel that pattern spotting is an essential part of problem solving?
Yes, I do, because through pattern spotting, it's helping the children to really sort of refine their explanation. And by refining their explanation, it's consolidating the understanding of the concept behind whatever I'm teaching. And by talking and by sharing their ideas, they're hopefully using the language of maths in the correct context. And also, they're seeing how it fits into the whole lesson as well. First of all, can anyone tell me, do you think this number is in the 3 times tables?
Yes.
Why do you say yes?
Because 120 is just double 60, and 60 is in the 3 times table, so, and then just add a 3 on it.
Give him a clap. Excellent answer. Well done. Fantastic answer. I love your answer. Right, I want to know if 123 is a multiple of 3. And here's how I'm going to do it in about 2 or 3 seconds. What does 1 add 2 plus 3 equal? 1 add 2 add 3 equals 6. Is the number 6 in the 3 times tables?
Yes.
So that means 123 is a multiple of 3. It's in the 3 times tables. Easy or hard?
Easy.
It's meant to be. What about this number, 321? Yes or no?
Yes, because 3 add 2 add 1 is the same as 1 add 2 add 3.
Good boy. Excellent answer.
I thought that the children's explanations of the strategies they were using was very spot on, and the fact that you encouraged that and you were accepting all their different explanations if they were correct, obviously.
Look at these numbers on the board. What is special about all of these numbers?
They're all even.
Good answer. Is that what you were going to say? Numbers in the 4 times tables have to be what?
Even.
Exactly. So multiples of 4, numbers in the 4 times tables, numbers divisible by 4 have to be even. What about this number? 315. Yes or no?
No.
What do you think?
No.
Why not?
Because it's odd.
Good girl. Lovely answer.
I noticed you hadn't introduced the word multiple as this means such and such a definition, but you started to use it within the lesson.
Right.
Now, it is a word that they would be familiar with and they should
Right.
really know in Year 4, and then they started to use multiple as well.
Right.
So you didn't introduce it as a new word, and I thought your modelling of the vocabulary was very good.
When we want to know if a number is divisible by 4, that means a number in the 4 times tables, we are looking at the last 2 digits. Is the number 17 in the 4 times tables?
No.
That means that number is not a multiple of 4.
Alison, how are they with problem solving in your class? Are they coping well, or do you think?
Well, there's 2 different areas. Firstly, when they have to understand what the problem's actually asking them and getting a grasp of what the worded problem is, and then choosing the right calculation, obviously, to figure it out. And then the situation where in a class you've got some who easily get that and are rapidly working it out and have the answer and are eager to tell you that they've got the answer, and yet others you can see are still sort of like trying to translate what the question is, but the others are sort of raced ahead, and how you actually sort of cope with that within the class and the range of ability.
Some of the things that I've tried in lessons is getting the children to act out the problem, actually physically doing it. And I think often they read a worded problem and they think it is completely unrelated to anything that goes on in the world. Whereas if they act it and they do it and they live it, they're more likely to be able to understand it.
There's a lovely phrase I use: when in doubt, draw it out. And once they draw, just as Adele said, once they can visualise the problem, they can have more chance of solving it.
And whilst you've got the children drawing it out, and is happy to keep going with that problem. The others, you can then give something to stretch them and move them forward so that they're feeling challenged and extended rather than just sitting around waiting for the others to catch up.
Yeah. Yeah.
So in today's lesson, what could you have done to challenge the brightest children? And it's on pattern spotting with numbers in the times tables. What might you have been able to do to stretch those top end?
What I will have done is I will have given the more able group of children a challenge of saying to them, can you give me a 3 or make up a 3 or 4 digit number that is divisible by 3 or that is divisible by 4. So to get them thinking beyond just a 3-digit number into a 4-digit number, into a 5-digit number.
You could perhaps provide them with, for example, a 4-digit number, but miss out some digits and tell them that this number must be divisible by 3. Can you make it divisible by 3? And then they have to think about applying the knowledge and filling in the missing digits.
And also thinking about it, they could look at other tables and see whether they can notice patterns in those tables as well and create their own rules for working those out.
Fantastic. So if they know the rule for the 3 times tables, how will that help them with the 6 times tables?
And are there
Brilliant.
similarities in the rules, or are there extra things that they have to do?
Yeah, well done.
Yeah.